What we're going to do is take a look at some examples and try to figure out some patterns. So what is binomial expansion? Now first off, a binomial is something that has two terms. And then we're talking about an expansion as in we're talking about raising it to a power. So then after we raise that to a power, we're then writing it in what is called standard form. So x plus 1 quantity squared would be a binomial raised to some power. In an expanded form, it would look like x squared plus 2x plus 1. So, of course you know this, but we arrive at that by taking x plus 1 squared and rewriting it as x plus 1 times x plus 1, and then we take everything in the first set. So we take this x, we multiply it by this other x, and that gets us our x squared. This x times this 1 gets us a positive 1x, or just x. And then we, after having multiplied the x by both things, we then follow through with the 1. So 1 times x, and then 1 times 1. So this starts after the distribution as 4 terms, 2 things times 2 things, but some of these terms, these two x's, are actually like terms, so we combine it such that we have 2 of those x terms. Now I'm going to rewrite this in a slightly different way. I'm going to write it as 1x squared, normally wouldn't write the coefficient, plus 2x to the first. Remember, anything to the first is just itself, so that's why we normally don't write it. Plus 1, this is a little bit tricky, x to the 0th. Anything to the 0, x to the 0, right, is equal to 1. So looking at this, this is another way we could write this. There is actually a reason we're doing this. To help give you that idea of why we're doing it, we need to take a look at the next example. So what about x plus 1 cubed? Well, we know that that's going to be x plus 1 times x plus 1 times x plus 1, which is the same as saying, well, we know what x plus 1 times x plus 1 is, which is x squared plus 2x plus 1 times x plus 1. And then we distribute x cubed plus 3x squared plus 3x plus 1. How do I know that? Well, that's part of what we're going to be talking about in terms of binomial expansion. But if you do take this x, you multiply by all 3 of these, and this 1 and multiply by all 3 of these, and combine your terms, you're going to end up in that same spot. So I'm going to rewrite this kind of like what I did last time. This is 1x cubed plus 3x squared plus 3x to the firsts plus 1x to the 0th, right? Okay. What if we changed it to x minus 1 cubed? So the big difference there is we'd have x minus 1 times x minus 1 times x minus 1. Now this is going to be a little bit painful, but I'm going to go through step by step here so we can make sure that this is going to be x times x, or x squared, minus x minus another x, and then plus 1, because we have a negative 1 times a negative 1. And just so we don't forget, we're going to write that we're multiplying by x minus 1 still. First, to make life a little easier on myself, I am going to combine like terms. Negative 1 minus 1 is negative 2. And now we continue to multiply, distribute that is. So the x, I'm going to multiply by all 3 of these. So x cubed minus 2x squared plus x, and then I'm going to multiply by the negative 1 minus x squared, and then plus 2x, and then minus 1. If I combine like terms, patience, it's a virtue, so please bear that in mind, I would end up with x cubed, negative 2x squared minus x squared minus 3x squared plus x plus 2x plus 3x, and last but not least, minus 1. And you guessed it, if you hadn't already thought of it, I'm going to go ahead and boldly rewrite this as 1 x cubed minus 3x squared plus 3x to the first minus 1x to the 0th. Okay? Now, if you'll bear with me, I'm going to bring some stuff together here. And we're going to try to figure out what sort of pattern we've got going on here. So we've got this from our most recent. Sorry. If we go back here, we've got this. Number U. And of course we've got, there, I found this right here. Okay, so if I take and move this all over here, we know that this came from x plus 1 squared. This came from x plus 1 cubed. And this came from x minus 1 cubed. Virtually the same numbers. We've changed the power. What did that influence? Well, 1, 2, after combining everything, 3 terms. After combining everything here, we have 4 terms. And wait, oh, 4 terms. What does this mean? Is there a relationship? If we're looking at squaring something, how many terms do we get? 3. If we're raising something to the third power, how many terms do we get? 4. Third power, 4 again. What if we did this? X plus 1 to the 4th. How many terms do you think we get? If you were thinking 5, you are thinking correctly. In general, for whatever the power is, we're going to get n plus 1, or 1 more than the power number of terms. Next pattern. What do we notice about the terms themselves? Well, it's a standard form, so the highest power goes first, in this case x squared, and then it decreases by 1. Highest power decreases by 1. And you can visualize that fully because x is still there, but x to the 0 looks a lot like 1. And that works out, well, every time. Now, here's the other thing. Notice the coefficients, 1, 2, and 1. What are the coefficients here? Remember, coefficients are what? Numbers in front of the variables. In this case, 1, 3, 3, and 1. Hey, wait, 1, but that's negative, positive, and negative. Virtually the same thing, except what's the difference? Well, those are both positive. But it seems that the signs alternate. Why? Because we started off with one of these things being negative. Remember, x minus 1 is technically the same as x plus negative 1 cubed. So by making one of these things negative, what did that seem to do? It seemed to make the signs alternate. So, let's sum up. Noteworthy items. For a plus b to the n, there are n plus 1 terms. That is 1 more than the power. The power of a starts at n, that is the highest power, and b starts at 0. We'll explore that a little bit more. The power of a decreases by 1 until it hits 0. Think x squared, x to the first, x 0. The power of b increases by 1 until it hits n. This is a little bit harder to see in the examples we did, but we'll be able to see it a little bit later on. There is a regular pattern in the number of times the term occurs. What I'm talking about there is, how many x squared terms were there here? 3. And 3x to the first terms, which is the same down here. And if a or b is negative, or we are subtracting, which is the same thing, then the sign of the terms seems to alternate. So we're going to leave it at that for now, and then we're going to start talking about why this is, and then looking at how we can expand things to even higher powers.